Hello, this is Jeremy, and in this video, I'm going to go through how to use the TI-83 or 84 calculator to find binomial probabilities. I've kind of jumped into the middle of a problem here, and the reason for that is that there's a couple of typical problems you might run across when you're doing binomial probabilities, and they're basic enough that I didn't see the need to go through them. One of the most basic ones is when I want to find the probability of a certain number of successes, so probably x equals c. Whenever I have that, and I can use the calculator very easily and use a binomial PDF and just input the number of trials, the probability of success, and how many successes I'm looking at. So in this example, I could say, what's the probability that the inventory meets the needs of exactly 3 customers? And I'd use something like this. The other very common type of problem is x less than or equal to c, c or fewer successes. So I could say, what's the probability that 10 customers walk into the store and we look at 3 of them and the needs are met for 3 or less? And that would be this type of question. And in that case, I use a binomial CDF. And what the CDF does is it starts at C and it counts down all the way to 0 for me. So it adds up everything below. But then I come to a question like this one. It says, what's the probability that inventory meets the needs for more than 5 of these customers? Now, I didn't really go through how this is a binomial experiment, and I'm not going to go too much into detail with that, but just remember we have a series of things we look for in binomial experiments to know that these rules apply, and they're all met here. So in this case, we have n trials, which is 8, and we have probability of success of 90%. Okay, so the question is essentially saying what's probably x is larger than 5, which you can see doesn't fit either of these possibilities for the calculator. So another way to look at this is using a picture of all the possible values of x, where x counts the number of successes. So it's kind of implied here that a success is that the inventory meets the needs of that customer. It could meet the needs of none of these 8, 1 of the 8, 2 of the 8, all the way up to all 8. And what this question is asking is for more than 5, so it'd be 6, 7, or 8. So one approach could be, and I wouldn't recommend this, but one approach could be is say, well, this is equal probability x equals 6 plus probability x equals 7 plus probability x equals 8. And then you could do PDF of this, PDF of this, PDF of this, add them up. That works great here, but what if there were 100 customers and we said more than 5? Well, now you're doing PDF of 6 plus PDF of 7 plus PDF of 8 plus PDF of 9, all the way up to 100. That's a lot of PDFs. Instead, what I can do is say, well, how can I use the CDF, which is a less than or equal? Well, the complementary event is everything essentially left over in the sample space. And if you look at this, that would be 5 and below. So I could say, just looking at the picture, that everything would be 0 up through 8. So that'd be a 100% chance that it's going to be either 0 or 1 or 2 up to 8. And then what's left over for what I'm interested in is 5 and down. That's essentially a complement. Using just the math symbols, I can say probability x is greater than 5 is equal to 1 minus the probability x is less than or equal to 5. Notice not only did the direction of the inequality switch, but this did not have an equals, and so this does. And so this is the complementary event. This is what's left over. And the 1 is accounting for everything. So it's saying this probability in the box is equivalent to 1 minus this probability. And so now I can use the calculator because that's a CDF. So this is 1 minus the binomial CDF of n, which is 8, p, which is 0.9, and c, which is 5. Now on the calculator, this is found under the distributions menu. And the way you get there is by pressing second and VARS. Now this is way down on the menu, so typically what I do is I press the up button first, and then I go and I'm able to find CDF. Now be real careful because CDF and PDF are right next to each other. And so before you even go into the menu, so I'm going to clear out of this. Before you even go into the menu, you type 1 and then minus. Then you go into the menu, second VARS. Go into CDF, binomial CDF. And then you're going to type it exactly as you see, 8, 0.9, 5. And when you go to do this, if you have a newer calculator, it's going to look a little bit different. It will ask instead for trials and probability of success. It's exactly the same idea. your final answer should be 0.9619. Right, so it's all about the complement here. Let's look at another non-standard type of problem. So in this example, I say, what is the probability the inventory meets the needs for 4 or more? So that includes 4, so it's x greater than or equal to 4. Well, remember, CDF is for less than or equal. That would be a CDF question like that. But this is a greater than or equal. So you say, well, maybe I'll use the complement like before, 1 minus the probability x is less than 4. Well, the only problem is that's not a less than or equals, right? Let's look at what's happening with that picture like we did before. So we got 0, 1, 2, 3, 4, 5, 6, 7, 8. We're still looking at 8 customers. When I say greater than or equal to 4, we're including 4 and up. And then here's the complement, 3 and down, which is the same thing as saying x is less than 4. So in other words, this is actually 1 minus the binomial CDF, which may seem weird because we don't have the equals, but keep with me for a second, of 8, 0.9, 3. Why 3 and not 4? Well, we're not including the 4, right? There's not an equals here. In the complement, there's not an equals. And if you look here at the complement, it's 3 and down. This step right here is kind of intermediate. If it didn't make sense to you, you don't even have to write it down. If you draw the picture, you can immediately see, well, if the event is 4 and up, then the complement is 3 and down. And that's what I use down here. And so when I go through and calculate this, the first thing I do, of course, is type by 1 minus. And then I go through the menu, I find the binomial CDF, type in the 8, comma the 0.9, comma the 3. I end up with something very, very close to 1. So I'll put approximately equals 1 here. So once again, the complement was able to help us out. You don't need the mathematical notation. This little drawing that takes you from 0 up to the biggest possible value of x is very helpful. Now, if I had 100 possible values of x, what I might do instead is draw just a piece of the picture. Draw maybe 1 through 10 and try to see if that would help me out. Okay, let's take a look at one more thing that could happen that's a little non-standard with binomial probabilities. Now this question is asking, what's probability meets the needs for between 2 and 5, and inclusive means we're including these customers. So in probability notation, this is 2 less than or equal to x less than or equal to 5. Okay, now I would highly advise immediately go into our little sketch that we had before. So I'm counting from 0 up to 8, because that's the number of trials. I say, okay, between 2 and 5, this is what we want to find the probability of. So one choice, remember, PDF does individual values. We could do PDF of 2 plus PDF of 3 plus PDF of 4 plus PDF of 5. But what if it was 1,000 trials and I said between 100 and 500 successes, right? That's not a good idea. So we try to find another way. Well, CDF counts down from whatever you put into it all the way down to 0. So if I do CDF of 5, it's going to count down from 5 all the way down to 0. Okay, I'm going to start with that. I'm going to say, okay, well, let's try that. Let's do binomial CDF of n, which is 8, p, which is 0.9, and then 5, counting all the way down. All right, but that counted too much, right? We counted the 0 and the 1, and we didn't want to. So now I need to get rid of those. How do I figure out what those are worth? Well, that'd be CDF of 1, because CDF counts down from whatever you plug in all the way to 0. So this would be minus binomial CDF of n, which is 8, p, which is 0.9, and c, which is 1. Now, when you put this one in the calculator, you're going to have to go through and do the CDF twice. So make sure your screen's clear, and so go to second and VARS, find your CDF, type in the 8, comma the 0.9, comma the 5. Make sure you close your parentheses. Now subtract. Go back into the menu, right? Second VARS. Find your binomial CDF. 8, comma 0.9, comma 1. Now you can press enter, figure out what it equals. You should get 0.0381. So as you can see, working with the calculator involves a little bit of really understanding what's going on with these probabilities. And you may say, well, I'm not going to use the calculator then. It'd be much easier to use the formula. The formula is even more clunky than this. It ends up having the same issues, and any technology tool you use will have the same issues. So in the end, you just have to get comfortable with how a probability distribution works and how you can apply it to doing these types of problems.